Hey friends, today we're going to take a look at how to assemble this USB-based MIDI fader or MIDI controller, which can be used for podcasting, live streaming, or just generally as a soundboard for your computer. It just sends MIDI commands over the USB and can be read via Mixxx, MIDI Mixer, Ableton, and many other softwares over the automatic learning tool. The parts included can be soldered by yourself at home with just some basic tools, and I would definitely recommend doing it like this because it's an interesting experience. At first, I'm going to sort and take a look if everything was inside the package, which looks good to me, so let's move that out of the way, and then let's take a look at the other stuff that was included. Perfect. So we're going to push in the 4 things that need to be pushed in from the top, which is the rocker switch and the 3, in this case blue, push buttons. I'm going to screw off all the nuts so I can just push them in from the front. We in total have 4 faders, 3 push buttons, 3 switches, the rocker switch we've already put in, and 7 5mm LEDs and 1 10mm LED, just to show some transmission going on. The project itself is open source, so you can take a look at my GitHub account, download the documentation, download some original files, so just suit yourself and feel free to rework stuff if you don't like it, or to write me a mail. I'm right now also pulling off the nuts of the switches because we're also going to need them later. This is going to take a while, but they just come out of the factory like this, so you don't lose anything in the beginning. The switches themselves I've chosen because they have a really awesome click feeling to them, and I know that a lot of people actually prefer buttons instead of switches, because a switch can be switched and the software doesn't know if it has been switched, so you can switch something in software but not in hardware, and I personally like switching stuff in hardware more because it just feels nice, and then you immediately know while looking at it for a second what's going on. The PCB you can see here is used mostly on the back side. The front side is completely empty, and the silk screen is white and the board finish is black, and the corners are rounded. That's actually to make it look more nicely, and I'm putting in the fader right here, but you can see the programming port which I've just hidden. So also the source code is open source, everything is written in Arduino, so if you want to change what this thing is actually doing, or if you want to implement functions on your own, or some kind of specialist niche applications, you can just download the code, change it, and then flash it onto the microcontroller on the back. Right now there's just the default programming on it, which works for me and probably for 95% of the people, but since I'm a big fan of being able to change stuff, I thought that you're also having the right to do that. So while putting in the LEDs, make sure that all the long leads are on the left hand side, because LEDs are directional, so the other parts actually don't matter that much or cannot be put in the wrong way around like the faders, but the LEDs can actually be put in the wrong way around, and they will not work if you do that. There are 2 debug LEDs on the back, which we are going to take a quick look later. So in case you have put in the LEDs the wrong way around, you can actually still see if something is happening at all. Before putting it down, I'm going to underlay something so that the LEDs just don't pop out on their own. Give me a second here. Perfect. Those are basically all the parts you will need. So to align everything, the acrylic front and the PCB itself, I'm going to put in the 4 spacers. The spacers are, I think, 6 or 8 millimeters tall, and are actually used for mechanical stabilization, and like I just said, the alignment of the acrylic and the PCB beneath it. The acrylic you can clean yourself, but please make sure to use something that can actually be used with PMMA, because the glass tends to crack if you use the wrong stuff on it, and that would be a shame. If that happened to you, just write me a mail. I can definitely send you a second one. But if you've already started assembling stuff, then that can be a real pain in the ass. So now that we have the spacers, we're going to take a look if everything fits. Since I built this, obviously everything's fitting quite nicely, and you can see some wibbly wobbly going on there, which indicates a perfect fit. So what we're now going to do is one by one just fit the parts in where they should be. So the push buttons actually don't need the nuts at all. The manual says that you can put them on, but practically they're not needed. So you can do that if you want to, but you don't need to. So now I'm going to screw one pillar on the back and one on the opposing diagonal edge, so that the acrylic glass in the front and the PCB cannot fall apart anymore. If you, like I did, screwed everything in completely in the beginning, you may that's a perfect example. You may see that you cannot screw it in like this, so you have to loosen the bolt on the top a bit, and then you can screw it in from the bottom more easily, because everything has some kind of wiggle room, so that you are actually able to assemble it, but not too much. Okay, so two of the buttons fell out again. Let's put them in again and then solder everything together. Now that we made sure that everything is at the right height, all the parts are in, everything looks good, and that we can actually assemble stuff. First, I would recommend lead-free solder if you're selling stuff like me. For personal use, the leaded solder is a lot better. Just saying. So what we're seeing here now is that the lead-free solder tends to stick a bit badly to the solder joints if the temperature is not right. Let's clean the iron, take a look. That's probably not working out. What we can see on the back is the ICSP programming header, like I said. Feel free to rewrite the code. Feel free to do everything you would like with it. That's the positive side about open source. Just suit yourself. Come on. The USB-C connector on the top is perfectly centered in the middle. I've been thinking about moving it to the side, but I don't know what kind of applications you're using it in, and having it in the middle has the advantage of being the most flexible. After the push buttons, the second thing I'm going to solder on is the rocker switch. This switch is actually rated for, I think, 10 or 16 amps, and we're switching, I don't know, not even a milliamp through it. That's why its spade connectors are this big. I'm not going to solder them on fully, because that's completely useless. In this application, I'm just soldered on so that I know that nothing will fall out, and then that everything looks good on the back side. The third hole for the rocker switch is so that you can mount it upside down, or you could theoretically even mount one with 3 positions, but electrically that would not make a difference anymore. It's just for your personal taste. These sliders are still a bit wobbly because they are not screwed on, and also the switches on the right hand side are just pushed in from the top. So let's start by putting the 3 nuts on the switches. They also don't need to be overly tight, because the acrylic glass on the one hand doesn't like mechanical pressure at all, so don't screw them on too tightly. And on the other hand, the switches are held in place anyway by being pressed between the PCB and the glass. So that's just for additional safety and stabilization. The switches themselves have little knob covers on top of them. By default they are green, but if you take a look at the internet, you can see that you can actually buy them in all different kinds of colors. So if you want something different, just write me a mail and I will see if I have some lying around. So what you can see here, that is already looking quite nice. The 8 needed screws, those are M2.5 to screw on the faders. Those are things that you definitely need to do before soldering them on, because if you've already soldered them, then you will most certainly not be able to screw them on in place correctly, because the holes for soldering the faders on are actually a bit bigger than would be needed, and that I've done on purpose, so that you can actually screw the screws in beforehand and not be limited by some kind of tolerances or different manufacturing stuff that would hinder you in doing so. So 8 screws it is, 8 screws are in. Now screwing them on, I would recommend starting on the one side and screwing in all the screws, but not fully tight, so leave quarter of a revolution left to be screwed on, just so that they can wiggle themselves into place and not have mechanical stress on them before you actually solder them. That's because you want to be using this product for a while, and if you start cracking the carbon footprint or the carbon track of the actually potentiometers, then they may suffer from that and may behave erratically. So now that we've screwed everything on, we can bring in the LEDs into position. So a lot of them had already fallen in place on their own. Yes, they look good. But some of them need a little push, so you can use a small screwdriver or whatever you'd like. Just make sure that you don't scratch the acrylic glass, especially at this point in time when you've already soldered in some of the stuff. You are not able to clean the glass or remove stuff on the bottom hand side. I'm going to use the solder wick again so that the LEDs don't pop out on their own while soldering them on, while I'm getting the nice, while I'm getting the lead-free solder in on again. And it looks like the solder has already started to be weird, so let's clean the tip again. That looks way better, and use a bit of fresh solder so that we have more flux inside, which can actually run onto the solder pad. That still looks really bad, so a bit more cleaning and then a bit more temperature adjustment probably. I'm most of the time soldering at 380 degrees C. I don't know how much Fahrenheit that are, but considering that the US is the only country using that, you can try to change that on your own in your head. So you see what I'm actually using for cleaning the tip. This is just a brass sponge, and I'm cleaning the tip now really thoroughly, because if you take a closer look, you can see that the solder joints are still not looking overly good. But with a clean tip and some fresh solder for reflowing, everything should flow into place quite well. And that you can see here that now the solder joints are looking much better. In the end, they should have a clear finish, like for the buttons you can see that they're quite shiny. This means that the solder has cooled off at the right speed and with the right conditions, so it makes a good both mechanical and electrical connection. I'm first going to solder one lead for each LED at a time, which you can see, so that I can make sure that everything's in place and that everything looks fine before soldering on the second one. So that's the last LED. Total there are 7, so it's not that many. What's interesting to note is that the rocker switch on the right hand side here is actually not an on-off switch, so it can be used in software. You don't have to turn the unit on or anything. It is turned on the moment you plug it in, and the rocker switch is for you to turn stuff on in software. Maybe that's a bit unintuitive at first, but in software, when you want to go live and you have a main rocker switch to go live, which has a red LED actually on top, then that's a visual cue that's really nice for me at least. So in out of the corner of your eye in a split second, if you see the red lights, then you know that you're on air, and that's something that I really, really like. For the software, like I said, basically all the different types of software can be used. I personally have tried it on a MacBook with macOS, a Windows laptop with Windows whatever, and even Ubuntu Linux. So all the big operating system providers are here, and all of them are supported as far as I can understand. So a really universal device, I would say. While I'm talking, you can see some of the switches. They have 6 connections each, out of which we only need 2. So if you're doing that at home, you can only solder the 2 needed connections, but I would recommend soldering all 6 because that makes them mechanically more stable and a bit better looking. Those solder joints on the back are for the sliders, so they have 2 joints on the top and 1 on the bottom, which means that you cannot put them in the wrong way around. Just if you were wondering, the switches you can put in both ways around. It doesn't actually matter. So whatever you feel, whatever they fall in your hand, they are symmetrical in their electrical connections. What you can see on the top right hand side while I'm soldering this are the 2 LEDs. They are quite tiny from this perspective, but they are more or less enough to see what's going on. They are the 2 most important ones used if you want to debug stuff, or if you want to actually see if you've short-circuited stuff while soldering. I would always recommend testing the unit on a current limited power supply after soldering. This I'm going to show you later. So I have a bench power supply over here, which I set to 5 volts, and the unit should never draw above, let's say, 200 milliamps. That's the most you're ever going to see. Even if all the LEDs are lit and you're pressing all the buttons at the same time and the microcontroller is doing really weird stuff. So that's why some kind of current measurement device for your 5 volt supply is good, because then you can immediately see if something's going wrong before stuff catches on flames or does something else that you definitely don't want to happen. Since everything is looking good so far, just the solder itself needs a bit of time. The solder joints need some time to warm up so that everything's looking fine. You can see that the black PCB is actually really prone for flux residue. That's why I said earlier that you really have to watch out for the acrylic while cleaning stuff. What I normally use for cleaning PCBs is acetone and PMMA, which is acrylic, does not really like to mix at all. So you have to watch out for this. And I'm using a small brush, and I'm really looking for that you don't actually have stuff going on the glass front side. So considering I've now seen 2 sharp edges, which you cannot see because I've moved them, I've cleaned them off, and now more or less all the solder joints should be fine. So a quick click through, clicky clacky, and now with my pliers I can cut stuff off. Those are special electronic pliers for cutting stuff off quite easily and at the perfect height in correlation to the board. I would not recommend cutting off the solder joints directly at the board height, but leaving a bit of the wire sticking out in the end. This helps you if you want to reflow or resolder stuff, that you can actually see what's going on. The only things that actually need to be cut off are the LEDs. If you really want to, you can also cut off the excess length of the rocker switch, but I'm not going to do that because it's on one hand quite hard, and in the other hand it does not get you anywhere because you need the height anyway above your table. So before trying anything out, let's do the two missing pillars. Those are M3 actually, and plastic, so that you can put everything on any surface and it won't get scratches, at least I hope so. And now I would say we're getting some cleaning in. Like I said, I'm normally using acetone. This is IPA. And please watch out for the acrylic. I cannot stress that too much. What I'm going to do is just trying to clean off all the flux residue. So this is maybe going to take a couple of minutes. If you're watching this tutorial to assemble one unit yourself, you can now skip ahead a minute or two and do that in your own time, in your own pace, and so that you don't have to watch me. If you're an electrical or electronics engineer like I am, you can also take a look at the schematics of this unit. It is quite interesting. The USB input, due to it being USB-C, actually has the correct USB-C power sinking resistors attached, and for the power supply itself, we even have a small ferrite bead to filter stuff, so that in case you have a really bad USB power supply, I'm not sure where you're going to get that from, but the unit itself should be quite relaxed with these things. So what I can see now is, I'm not sure if the solder joint over here is looking too nicely. I'm quite sure that I want to rethink this, but let's first clean it a bit more and then take a look. Yeah, probably a bit more solder. The rest on here I'm going to wipe off. Now the unit should look like this, which is quite nice. A bit sticky still, but I don't want to use too much of the IPA. Like I said, here you can actually see the reflection of my bench supply. And in the end, we're going to stick on those 3 rubber knob heads. Like I said, there are different colors available. I'm just having green because I like green personally, but there are many different others. And this unit will be assembled with pink fader knobs. The fader knobs on the pictures actually have a mark in the middle where I've marked them with some nail varnish. I would recommend you doing that yourself if you want to. There are, at least my girlfriend has a few different options for that, but if not, then just leave it like this. So here you can see my current limited power supply, and I'm going to plug in a USB-A to USB-C cable. The cable itself right now only has power applied, so I can only see if it is working at all. And that looks great, so everything lights up. Let's try out everything. The 10mm LED on the bottom hand left only lights up if something is changed. So it is as a visual debug mechanism. If you want to see stuff being sent to your computer, then it lights up. So it's really dim, but that's on purpose, because in a dark environment, you don't want to debug stuff all the time. You just want to be able to see stuff. that's how it's going to look like in the end. In the back, the two LEDs, like I said, okay, they are way out of focus, but if those are lighting up, then your unit is receiving power, and if it is working like I showed you, then you are fine. Have fun.